In this video, we're going to cover all the content from the AQA specification on forces doing work. We'll look at work done, deformation of objects, and elastic deformation. That's everything you need to know in 5 minutes. We know from paper 1 that forces are a way of transferring energy from one store to another. When a force makes an object move, it increases the kinetic store of energy of the object. We say the force has done work. Work done is the same as energy transferred. Here's a person exerting a force and transferring energy to an object and moving it a certain distance. The amount of work done or energy transferred is equal to the force multiplied by the distance. It takes 1 joule of energy for a force of 1 Newton to move an object by 1 metre. We say that 1 joule is equivalent to 1 Newton metre. Not all of the work done by a force is always used to increase the kinetic store of energy of the object. If there is friction, then some of the energy will be used to overcome this. In this case, there is an increase in the thermal store of energy of the object and its temperature increases. When more than one force acts on a stationary object, it causes the object to change shape, or what we call deform. Common deformations are for the object to compress, bend, or extend. If an object returns to its original shape once the force is removed, we say the deformation was elastic. An example of this would be a rubber band which returns to its shape when you let go. If an object does not return to its original shape once the forces are removed and it stays permanently deformed, we call this plastic deformation. For example, when you crush a drinks can. A spring is an elastic object. When you apply a force, the spring will extend. When you remove the force, the spring returns to its original shape. The force applied is linked to the extension by the equation force equals spring constant, that's a measure of the stiffness of the object, multiplied by the extension. And this equation applies to any elastic object, not just springs. A graph of force against extension for an elastic object looks like this. The first thing to note is that it's a linear relationship and the line passes through the origin, which gives us an important law of physics. The extension of an elastic object like a spring is directly proportional to the force applied, provided the limit of proportionality is not exceeded. What does this last bit mean? Well, if you've ever pulled a spring with a lot of force and really stretched it, you'll have found out that the spring doesn't go back anymore. You've plastically deformed it, and it no longer returns to its original shape. The graph would start to curve at this point, and the point between where it's linear and non-linear is called the limit of proportionality. The spring constant is a fixed number for every elastic material. You can find the spring constant by finding the gradient of the graph. Finally, a force pulling down on a spring does work. This increases the elastic potential store of energy of the spring. You can calculate this using the equation elastic potential energy is a half multiplied by the spring constant multiplied by the extension squared. This is given to you on the exam, you just need to be able to use it. Thanks for watching, I hope you found it useful. Download a copy of the notes from this video on my website missbroom.co.uk. Get daily updates and your questions answered on my Instagram and Facebook pages. And to help other people find these videos, please hit like and subscribe.